natural numbers. They're just the counting numbers, the positive integers, 1, 2, 3, ad infinitum. Okay, some people, these are called the positive integers. Some people include 0 in here, but clearly 0 is not going to be a solution to this. And you're given some powerful information. All these fractions, the product of these two fractions summed with this fraction, when you take the square root, you actually get a natural number. So that's useful to know. Now, this is a common form right here. If you could write all of this as the square root of a plus b quantity squared, the answer would just be a plus b done, right? And so, like for example, b squared is discernible right here. So 121 over 81, okay, is equal to b squared. That would tell you that b has to equal to the square root of 121 over 81. So b would be what? 11 over 9. Okay, so that's all good and fine, but if you'll notice here, we're not going to have a whole lot of luck with the rest of this, because you see this part right here, I don't see a way for these two terms, a squared plus 2ab, to equal to all this stuff. I don't know. There may be a way, but I sure don't see it. So it turns out there's another approach that to me is a little more straightforward. Right here, this is the well-known difference of two squares formula. But that's equal to a squared minus b squared plus b squared. So you see how nicely the b squareds cancel out and you just get the square root of a squared, which is a, right? Now we've seen in the previous step that b is going to be, let me get this straightened out here. Okay, b, let's just write it down. Okay, so now the way you may want to approach this is just go ahead, you know that b has to be 11 over 9. Okay. But in order for you to get 920, you need what? 909 up here? So you would have 909. Over 9 right there, right? So you see, folks, now this would be functioning as your a plus b right here, right? 901 plus 11 is the 920 that you see right there. Okay, then in a similar fashion right here, you would get 909 over 9 minus 11 over 9. Okay, so that's pretty good news for us. But you see, it's clear that a is equal to 909 over 9, right? All right, from this situation right here, and the difference of two squares results leads to all this cancellation. And so you see, you just get 909 over 9. 909 divided by 9. And I wrote this in advance just so you guys wouldn't have to watch me write everything down and make mistakes. But I hope you guys see the structure. It's really, really nice. You work with something that's familiar and see if it fits the rest of it. And it worked out in this particular case. Okay. Now, so 9 over 9, 909 over 9, excuse me, 909 over 9. Equals to 101. And it did end up being a natural number. Definitely a member of the natural numbers, folks. And so that is the solution. I hope you liked it a lot. I kind of enjoy these sort of problems, just dealing with natural numbers and manipulations, algebraic identities that help us get to the solution.